My talk will be about the lack of zero-cost abstractions in JavaScript. So let's start. But first, some disclaimers. So we actually have 4 major JavaScript engines. And the last one actually got open sourced by Microsoft, which is really nice. Yay. And some more which are less widely known. But the point I'm trying to make here is that there's a wide variety of engines, and all have different performance characteristics. And yeah, different optimizations, performance characteristics, and the stuff I will show you, I won't show you any numbers here today. So and all the code I'm showing is actually modern JavaScript. What I'm trying to do is just get you into the mindset of what are things you can look for when it comes to like performance in JavaScript, and what common patterns there are that are not so good for performance. So what does it actually mean to have like zero cost abstractions? JavaScript is just-in-time compiled, and it's a very dynamic language. So it's as opposed to like ahead of time compiled and very strictly typed languages. So in compiled languages, there's a lot of things the compiler actually does for you before you hit the runtime. And in JavaScript, that's simply not the case, because most of the stuff you do is done at runtime. Of course, there are these highly advanced JIT engines that can optimize a lot of things out, but the point is, don't rely on those. So the rule of thumb is basically, if something looks like a function call in JavaScript, it is a function call. So, and as I said, JITs may be smart, and sometimes they can optimize things out, but don't rely on that. There's actually some languages out there, so not JavaScript, but there are some languages that have like also unit tests for things like big pieces of big pieces of code that actually have absolutely no runtime costs. So in other languages, you also have unit tests for that, or like whole stuff of function calls and structures and whatnot. And other languages can also unit test that it doesn't even allocate any memory for that. It's sadly not the case in JavaScript. So, but JavaScript is very popular, obviously. So there's a lot of people here. And one of the good things about JavaScript is that you can be quite productive with it. So there's a lot of nice frameworks and nice abstractions. You can get started really quickly, and you can get to a product really quickly. But there's always a trade-off between like the developer productivity and the actual runtime performance. So let's start with actual examples. So this is a pattern that was kind of popular some time ago. Fortunately, it is not anymore. So it's like JavaScript as a language does not have private class members, instance members. So there's a few things you can do to kind of emulate the thing that privates are. One of those patterns is that you have a constructor function which does not actually manipulate this, but returns an object. So in JavaScript, when you're using the new operator, and the function actually returns an object, that's what's used for the result of the new operator instead of this. So that was a common pattern some time ago, but it's actually quite bad for performance, because every time, every single instance has its own copy of every single method. So it's a fresh function object, and it's also bad to debug and inspect. Good thing is, now with the new ES6, so modern JavaScript, you can actually use symbols, and you can define properties on this using symbols, which act like private instance variables, because no one can actually access them without the access to this specific symbol here. So it's impossible to access them outside. But it's also nice to debug and to inspect, because your inspector can list everything. But there's actually when you're calling the method getA, it actually has to do a prototype lookup. So it looks at the object. There is no getA inside your instance itself, so it looks at the prototype of the object. So that's basically the myClass.prototype.getA. That's one step further away. But actually, the prototype lookup is one of the most heavily optimized things in JavaScript implementation. So that's probably not so bad. Well, another example is closures, which are really nice. But especially with the new arrow functions, it's always, sometimes they get a little bit hard to spot because you have closures everywhere. And every time you're using an arrow function, you are allocating a new function object at runtime, which is probably not what you meant to do. But unfortunately, in this example, for example, in your Redux async action creators, it's really hard to avoid because you actually need the closure to actually close over an outer argument. So that can't be avoided here. But I will show some other examples. So promises are really awesome and nice, apart from being uncancelable, which is crazy what you have to do to actually, well, cancel or react to something, to some promise that you have a listener on, but you're not actually interested anymore in the result of the promise. But the thing with promises is, let's rewrite this a little bit. Thing is, with every then chaining, you're creating a new promise object. New promise object which has its own listeners, which can get chained to another promise, and so on and so on. And this also led to some headaches in our code because I actually saved the wrong reference to the wrong promise, and it got my caching all wrong. But well, my speaker notes say there's still something missing from this example. Let's go one step further. So actually here we have like these arrow functions, which are nice to write but hard to spot. So as a next step, we just extract this arrow function. So we create it like once and then reuse it. So imagine this is like in a global scope, and this here below is like in a function call. So you are not allocating new functions for all those arrow functions you are using. Well, another example is actually React and JSX, which one of the goals of JSX is to bring like so-called declarative templates to JavaScript, which are really nice to use. It's really awesome, but they have a runtime cost. Because actually what the compiler does is it transforms these JSX tags into function calls, which then in the background do some other computation and so on and so on. And you have tags which are not changing, like the span here, but the compiler always calls this method, and it's always allocates like a new React element. That's what React create element does. And React internally has to do some housekeeping to actually figure out that the element didn't change. So there are also some React alternatives. This is an example I found a few days ago, and it made me instantly go like facepalm. Because what this example here does is, you can see you have a tagged template literal. So it's actually a function call, obviously. But a template string, so like this template literal also means that it's a string. So you actually have to parse these HTML fragments at runtime every single time you're re-rendering your stuff. So it's not like in React that it's a simple function call, but it's actually, from this example, you should be able to see that it actually needs to do string parsing at runtime every single time. And also digging deeper into this particular library, the DOM diffing itself is done using actual DOM elements and stuff like JavaScript objects, which is another facepalm. But I don't want to criticize too much. Okay, thing with JSX is, like the example I mentioned, the span does not ever change. And there's also some compiler plugins that can move like these constant elements out of your render method, so you don't have to recreate the React elements every single time. And another thing is avoid doing like inline bind or arrow functions in your React render methods, because it creates a new function object, which is different from the props you passed in last time. So unless you do some crazy should component update optimizing, it will re-render all the children as well. That's just something. There's also, if you're using eslint, there's also the eslint React plugin, which warns you about cases like this. But the problem is, if you're using the new functional components, there's unfortunately no way around it. All right, and now meta programming. Some time ago, I actually thought my worldview on programming languages and typing changed a bit. For example, especially because of things like union types, which are available in some languages, but not in others. And you can emulate some functionality like this in JavaScript. Like, for example, this library, you can define a union type action, which can be either up, right, down, or left. And it could theoretically also have some parameters. And you can case or match on them and, well, actually use union types as they are meant to be used. The problem here is, I've also annotated this code example that there's a lot of function calls, and you're actually allocating every one of these arrow functions are allocated every time you're doing a match or a case expression here. And it's just something that should be avoidable. Luckily, this library has something like this, so you can define your matching expression or your reducer or whatever that you want to call that once, and it only allocates like the arrow functions once and the implicit object once. So that's a lot better. So now that's an exercise for you guys. So what actually is the runtime cost of this? Anyone? Hands up, come on. So what happens here? It's an easy piece of code.
15 function calls? Or 15 functions?
Wow, I don't know. Well, depends. If this would be in a function that you call often, of course, the arrow functions would be created every time. But yes, that's one thing that happens. And the other thing, someone? Come on, yeah.
I know what's happening here. You have an election, then you map on election, then you apply filters and reduce all this election.
Yeah.
So first is you simply multiply all this item in election by 2.
Okay.
Then you filter odds.
I'm not really meaning what the result of the code is, but what like the runtime cost of this is.
Maybe 2?
I don't want the results.
42.
I don't want the results.
3n.
Nah, come on, guys. Okay, I will lift the secret. The point I wanted to make here is that you have like this array and you map over the array. Okay, but by mapping over the array, you create a new array. Then you filter over this new array, creating another new array, and then you reduce it, which is like, yeah, you're creating like 2 or 3 implicit arrays here, which could be avoided if you had better abstractions, which JavaScript simply does not, except if you're using some kind of transducer library or something like this, yes?
But in this example, the reduce is never ran, is it? Or on an empty
course
array
it's
at
ran.
least?
What?
On an empty array, is it? Or did I miss something? Because if you
Every-
multiply everything by 2 and then call person...
The point is not what the actual result here is, but you know. All right, so the conclusion from my whole talk is that developer productivity is really awesome, and it's enabled JavaScript to get where it is now. Like, it's the most popular language like out there on Stack Overflow and GitHub and whatnot. But it has runtime costs, and there are compilers, like, for example, there are Bubble plugins for JSX that can do like optimize out constant React elements and also do dead code elimination and things like this. The point I wanted to make is so that you guys here and girls actually pay attention and develop like the 610s for what your code actually does at runtime, and not what the result of the code is, but what the actual execution steps are. So the outlook here is that JavaScript, and especially the variants SMJS and WebAssembly, which is being developed right now, is actually a compiler target right now. You have like JSX, you have Babel, you have TypeScript, and every single bundler parses your JavaScript and compiles it into a different kind of JavaScript. And of course, C++ and all the LLVM languages you can use via AmpScript in, they are all compiled to JavaScript. So JavaScript is your compiler target. So maybe let's just embrace it and do more and more optimizations actually at compile time instead of at runtime. That would be something that would be really nice to do. But somebody has to do it. So that's basically it. I hope you liked the talk. And are there any questions?
Maybe just repeat the question, because otherwise I have to speak into the iPhone.
Okay.
Because you just at your former slide you wrote that you wanted to raise awareness. Did you ever hit the, because I've been developing JavaScript for like 3 years, so not so long. But except for my experiences with Angular, I've never really hit the like performance bottleneck of JavaScript as much as I would say I would have to performance optimize my code.
Okay.
So
the question was basically,
the question is
it worth it doing?
Yeah, is it worth it? Do you really have to think about it? Because nowadays still the except when you make native, not native applications, but apps for like mobile apps, where yeah, performance is really important. Let's say.
I would
really
say.
important. Have you ever met such problems in real life?
So the question was basically if performance really matters that much, and I would say it does, especially on mobile. At our company, I'm jokingly known as the chief scrolling engineer because I have to optimize scrolling and make sure that it actually runs at 60 FPS, which is so damn hard, you wouldn't believe, because a lot of JavaScript runs during the scrolling, and it's loading new stuff dynamically on the fly, and it's rendering stuff with React, and so on and so on. And it makes the scrolling hang for a little bit. And
so basically what you're saying is, yeah, it's important, especially for mobile devices.
It's always important.
It's always.
It's and as you said, JavaScript is increasingly used for native development using React Native and some other things. I think, do we have another talk?
JavaScript talk.
Yeah. And I'm really excited to hear it. And actually, I think what the native via JavaScript approaches are trying to do is to actually bring the productivity that JavaScript can offer to the native platform, but actually with the performance benefits of the native platform. So it's kind of like a hybrid approach. And there's also a lot of things the developers developing the native shims need to do is to optimize for performance. So.
I'm not very familiar with JavaScript build systems,
But since you told us that JavaScript is actually a compiled target, do you know of any built tools that compile your JavaScript into optimized JavaScript? Like does not do the lambda allocation, like it factors out in a function or whatever?
There are some plugins, like Babel is more or less the de facto compiler right now for JavaScript. It does all like JSX and other things, and like compiling ES6 down to ES5. And there are some plugins for Babel that actually do like closure elimination. So if the closure does not depend on any variables inside the scope, it just moves the closure up to the top level. So the actual function object is only allocated once. Those already exist. But I would really like to have cases like this, which exist in other languages but do not exist in JavaScript. I would like to have union types and generalized algebraic data types. That's the special term for them.
You could do Scala.js.
Yeah. You can do a lot of things with other, like all the LLVM toolchain languages, but it hasn't been done so far to the point I would like. Okay.
So in your mobile scrolling adventures, is your main bottleneck the memory or the CPU?
I think it's the CPU, because it's there's like in JavaScript when you're okay. Let me think a little bit.
Mobile, right?
Okay, it's on mobile. Yes, it's on iPads and phones and things. And for example, when I'm scrolling, I'm dynamically injecting new content. So it's like an infinite scrolling thingy. And when I do it, I have to fetch something from the network. I have to process the things I fetched. I have to render it using React, which of course has like all the React-specific overheads. And that actually makes it skip one frame, for example.
And you can't really use other cores, right? So you can only use one core.
Yeah, JavaScript is single-threaded. Yeah, JavaScript is single-threaded. And actually the browsers are doing a lot of rendering optimizations, which actually fuck up everything else you're doing, because you don't get scroll events that actually match the things that are on screen. And maybe you don't even get scroll events at all. And yes, it's...
That's why you have to work out so much.
Yeah. Yeah. Right.
Do you have experience with any of those transpilers, like I don't know, CoffeeScript or TypeScript?
I haven't used CoffeeScript. I haven't used TypeScript. I'm using like modern JavaScript.
Okay.
I've done some experiments with Flow, but Flow is just a type checker, so it doesn't actually optimize your code.
Because I guess they kind of, I don't think that they meet all your requirements, but I think they're improving.
There's also,
because even if because when you have got static typing, you can do a lot of more optimizations.
yeah. There isn't much I've done personally, but I'm reading a lot of things about, for example, PureScript, which is like a Haskell dialect, which is specifically designed for JavaScript, and also Elm, which is another Haskell dialect specifically designed for JavaScript. And both are really strict type-safe languages, which also have like these union types I mentioned. And they compile to JavaScript, and they can optimize some code patterns a lot more compared to what you could do by hand.
How much does garbage collection get into the way?
Depends on your runtime. Actually, the garbage collection is highly optimized. So temporary objects, which are deallocated really fast, doesn't cost so much, but they still have a little bit of overhead. So you shouldn't just allocate objects all around.
You have to differentiate between games and
Yeah.
I was just
websites.
thinking
Or
about the
websites.
scrolling.
Because if you have time in the middle where your CPU doesn't do anything, it can do garbage collections. If you have games which run all the time on all the resources, then it's a problem.
And the problem is also, I think, from my perspective, the problem is also JavaScript itself. Because, for example, if you have like AAA high-end game on the PC or on the console, it runs at 60 FPS, and it delivers stunning graphics. And 60 FPS means it has to finish one frame in 60 milliseconds. And for example, in JavaScript, when I actually load my 1 megabyte bundle, even parsing and actually loading the bundle JavaScript takes like 200 milliseconds. That's like, I don't know, a fifth of a second. If you need to run at 60 FPS, that's simply not.
It's just the fact that it's often really, if a developer guesses what is in performance expensive and what is cheap, the developers often guess wrong. So, for example, fucking CSS repaint costs so much just because it's so many objects that you have to draw and to calculate, and if you don't know the height and width of stuff, it's really hard. And again, they probably just know the width and height and depth of everything.
Yeah, exactly.
And so they have other problems to deal with.
So, no more questions? So, thanks for your attention. And I'm actually planning to do a follow-up talk sometime. So, actually digging even deeper into depth about what actually happens from your like business data until things get drawn onto the screen. So, thank you.
Thank you for watching this talk. Down below you can find our channel ViennaJS, where you can find a lot of different videos about front-end and back-end JavaScript, and feel free to subscribe.